In question 8, we are given a question about polar coordinates, and we are given this graph and the equation for it. Now we are given a point A on this graph, which meets the linear initial line. So the angle over here is 0. So a polar point is denoted by its distance from the center or origin r and its angle from the origin. So you begin the angle from here and go like this. So this is at 0 degree. So we have a theta of 0. So the value of r over here will be 6 1 plus cos 0, which would be 12. So the polar coordinates of A would be 12, 0, since theta is 0 and r is 12. Now in the second question, we are given line L1, which is the tangent to the curve at point B, and it is parallel to the initial line. So this is the initial line, and L1, which is tangent to B, is parallel to it. Now if you look here, there is no change in the y value, so dy by d theta would be equal to 0. Now in polar coordinates, x is equal to r cos theta and y is equal to r sin theta. That's how you find the value. It basically uses trigonometry, because this value over here is r and this is theta. So this is r sin theta, this is r cos theta. That's how to do it. Now we know that dy by d theta is 0 for line L1. So d times r sin theta divided by d theta is equal to 0. Now if I want to find this out now, r sin theta is r 6 plus 1 plus cos theta, which is r 6 1 plus cos theta, and you multiply the entire thing with sin theta. D theta equals to 0. If you simplify the expression, you get d by d theta of 6 sin theta plus 6 sin theta cos theta. And if you differentiate this, if you differentiate 6 sin theta, you get 6 cos theta. And for integrating, for differentiating the next, you need to use the quotient rule. So you have 6 sin theta cos theta over here. You assume one of them to be u, the other one to be v. Now du by d theta is equal to, if you differentiate 6 sin theta, you get 6 cos theta, and dv by d theta, if you differentiate cos theta, you get minus sin theta. So finally, the result we get is u times dv by d theta plus v times du by d theta. This is u is 6 sin theta, so 6 sin theta times dv by d theta, which is minus sine theta, plus v, which is cos theta, times du by d theta, which is 6 cos theta. So this is 6 minus 6 sine squared theta plus 6 cos squared theta. So minus 6 sine squared theta plus 6 cos squared theta. Since we already have a cos theta over here and another cos squared theta over here, I'll convert this sine squared theta to cos squared theta using this identity. Sine squared theta plus cos squared theta is 1. So sine squared theta is equal to 1 minus cos squared theta. So we get 6 cos theta minus 6 times 1 minus cos squared theta plus 6 cos squared theta equals to 0. 6 cos theta minus 6 plus 6 cos squared theta plus 6 cos squared theta equals to 0. So we get a quadratic equation over here. 12 cos squared theta plus 6 cos theta minus 6 is 0. So you can let y equals to cos theta or something else. I'll let p be cos theta. So we get a quadratic. 12p square minus plus 6p minus 6 is 0. If you solve this, you get 2p minus 1 times p plus 1 equals to 0, and the 6 here. In F2 you can just use the calculator for this. So p is either half or p is minus 1. So cos theta is half or cos theta is minus 1. Now we get two values of cos theta, but only one will be necessary. You can already figure out which one to eliminate here. Cos is only negative in the second and third quadrant. So when the angle is between pi by 2 and 3 pi by 2. If we look over here, this angle is less than pi by 2 or less than 90 degree. So it can be that. So we need to find, since we don't need this, we'll just find the value of theta from here. This is cos inverse half, and you want to find the answer in radians. This comes out to be pi by 3. And we aren't done yet. We just know the angle of B. We want to find the coordinates of B, so we'll place this value of theta equals to pi by 3 in the equation. R is 6 times 1 plus cos theta. Theta is pi by 3. So R is equal to 6 times 1 plus half. So R is 9. So the coordinates of B is 9 comma pi by 3. Now for part C, we have to find this shaded area R. Now to do that, I first need to find this area over here of the segment. Using the polar integration, you get this segment area, this sector area, and from this sector area you can subtract this blue triangles area to get this segment area over here. And now you have another triangle over here. I'll do it in purple. This triangle over here is another triangle. Now if you subtract the black area from the triangle area, you get the shaded area R. So first, it would be useful if I know the Cartesian coordinates of A and B. So I'll do that first. The x coordinate is r cos theta for A. I know the polar coordinates of both. For B it's 9 comma pi by 3. For A it's 12 comma 0. So the x coordinate of A is 12 cos 0, which is 12. The y coordinate is 12 sine 0, which is 0. For B, the x coordinate is 9 cos pi by 3, which is 9 over 2. And the y coordinate is 9 sine pi by 3, which is 9 root 3 by 2. So we can find the area of triangle OAB. It would be half into the base, which is 12, times the height, which is the y coordinate of B, which is 9 root 3 by 2. So this is just 27 root 3. And area, I'll name this point P for convenience. So area of triangle PAB is half times the base. The base of this triangle is this distance over here. This is the difference of the x coordinate of A and B. So 12 minus 9 by 2, which is equal to 15 over 2. So half into 15 over 2 into height. Height is the is the y coordinate of B again. So 9 root 3 by 2. This comes out to be 135 by 8 times root 3. After this, I want to find the sector area OAB. Now for the segment area, I need to do polar integration. Now the area under the graph for a polar curve is given by this formula over here. It's half times the integration of r square with respect to theta. Now this is what we get. In this case, the limit theta 1 to theta 2, if we look at the graph here, theta 1 is the angle at A, which is 0, and theta 2 is the angle at B, which is pi by 3. So we put those values over here, here and here. Now we continue. So r square is 6 plus 6 cos theta, and we square it. And on the next line, we expand the squares. So we get 6 squared plus 2 times 6 cos theta plus 6 cos theta whole square with respect to theta. Now we can find out the values over here. Now if you notice, we can integrate 36 directly. We can integrate 72 cos theta directly. But for 36 cos squared theta, we need to manipulate this. Now if you notice, this is the formula to for sum of angles inside a cos. Now if both A and B are theta, so this case cos A times cos B becomes cos theta times cos theta, or cos squared theta. Same case for sin AB or sin A sin B. So in the next line, we can write cos 2 theta is cos squared theta minus 1 minus cos squared theta, since sin square plus cos square is 1. Then we get cos 2 theta, which can be written as cos square minus 1 minus plus cos squared theta. So this becomes 2 cos squared theta minus 1. Now if I make cos squared the subject, I can get it in terms of cos 2 theta, which I can integrate directly. So if we do this, cos squared theta becomes cos 2 theta plus 1 divided by 2. So if I write this over here, I get this. So I just wrote it as cos 2 theta by 2 plus half. Now if I multiply the 36 inside, I get 18 cos 2 theta plus 18. Now I can add the 36 and 18 together, get 54 plus 72 cos theta plus 18 cos 2 theta. Now I can integrate it directly. If I integrate 54, I get 54 theta. If I integrate 72 cos theta, I'll get 72 sine theta. And if I integrate this, I'll get 18 sine 2 theta divided by 2. And the limits are from 0 to pi by 3. So now I'll put the limits in. So 54 into pi by 3 plus 72 sine pi by 3 plus 9 sine 2 pi by 3 minus 54 times 0. So we have 54 times 0 plus 72 sine 0 plus 9 sine 0. This becomes half 54 pi by 3, which is 18 pi plus 72 sine pi by 3, which is 36 root 3, and finally 9 sine 2 pi by 3, which is 9 root 3 by 2. And then we have minus 0 from here, so it won't affect anything. So finally we get 9 pi plus 9 pi plus 18 root 3 plus 9 by 4 root 3. I can add the root 3's together. I get 9 pi plus 81 by 4 root 3. This is the sector area. This is this whole red area. Now if I want to find the segment area, I need to subtract the area of triangle OAB. So this sector area is this expression over here, and now I need to subtract the area of triangle OAB. So this blue triangle OAB, and I know that it's 27 root 3. So I subtract 27 root 3 from here. I'll get 9 pi minus 27 by 4 root 3. Now this is the segment area. We're still not done. The shaded area will be equal to the area of the purple triangle. So area of triangle PAB minus the area of the segment. So the area of triangle PAB we have calculated earlier. So this purple one, this entire triangle is 135 by 8 root 3. And the segment area is 9 pi minus 27 by 4 root 3. So this becomes 135 by 8 root 3 minus 9 pi plus 27 by 4 root 3. So this becomes 189 by 8 root 3 minus 9 pi, and that's the answer.